Okay, so we've been looking at equations. I want to change focus now and start to look at the concept of inequations. And inequations are a concept you've just got to wrap your head around quickly. And once you've got it, you'll notice there's not much difference to equations. So I'm going to start here with our inequations. I'm going to start by looking at this particular bridge and the fact that it says low clearance 3.5 metres on the bridge. And I want to discuss that in terms of equations and inequations. Alright, so I'm looking at this bridge, and I want to write a little statement that kind of sums up the height of cars or vehicles that can pass under this bridge. So I'm starting to look at this low clearance. I'm thinking that maybe I could write a statement like h is equal to 3.5, where h is the height of a vehicle that can pass under this bridge. But then what happened was this vehicle came along. And as this person was driving, they slowed down greatly. And it reminded me of the sorts of images you often see on the internet, such as this. I don't know how clear this is going to be. You can see that. Where you see the bus getting stuck right under the bridge, which made me rethink my h equals 3.5. And I started to think, well, actually, I think what I'd rather have happening here if I was this driver was to have my h is less than 3.5 to avoid that other case. And this is where we start talking about inequations. So before I had just one height of vehicles that was going to pass under the bridge, the h equals 3.5. Now I'm starting to talk about a range of heights. I'm starting to say that I really want my height to be less than 3.5. So as long as this vehicle is less than 3.5 metres, it should be able to pass under there. And in fact, at the start of the video, you would have seen a car pass under the bridge. It was definitely less than 3.5. There's a whole range of heights that can make it under this bridge. So rather than being an equation with only one answer, it's an inequation with a group of answers. And the answers are all the heights that are less than 3.5. But of course, because these vehicles exist, we could say that all these heights have to be greater than 0 as well. So we have our heights in a range of solutions, and that's what happens when we solve inequations. We can also represent this range of solutions visually, and we can actually do this on what we call a number line. Draw a number line, say this is our representation of h, and what we'll do in the number line is mark in a definite point. We'll mark in 0, it's a good reference point, and then we've got 1, 2, 3, 4. So in the middle here will be our 3.5. Now we're saying that the heights of vehicles are in this range between 0 and 3.5. But I don't want to include 3.5, so I'm going to draw a circle around it to indicate that I'm not actually including it, because I don't want to end up like this bus here, stuck under the bridge. I have to be bigger than 0 to exist, so I don't want to include 0 either, so I'm going to have a round circle there. And then I'm going to say it's all of these answers in between, and that's how I represent this visually on a number line, this set of inequations. So getting down now to, I guess, actually solving inequations. When we actually have to solve inequations, they actually are set up much like an equation. So it might be something like solve a minus 3.5, there it is, it's in my head, is less than or equal to 9.8. And it's just going to be like an equation. This is nice and simple. It's one step. We're just going to keep this less than or equal sign here and keep the balance in it and say the inverse is to add 3.5. So add 3.5 to both sides. So I'm going to get a is less than or equal to, adding that together is 13.3. Now if I want to graph this on a number line, again I'm going to draw a straight line. I'm going to call the line all the numbers that a represents. I'm going to mark a reference point of 0 in and say it's less than or equal to 13.3. So rather than scaling it out, I'm just going to say there's my 13.3 over here. Now this time it's less than or equal to, so I'm actually going to want to include 13.3. I'm going to put a coloured dot in there, and it's all of these values down here that go this way, and there's no other value on the other end to stop it. So all these values work. I'm going to put an arrow here to indicate it keeps going on forever in that direction. Solving an equation is just like solving an equation. You just work through it, making sure you keep your signs nicely in line, and you do all the processes that you would normally do for solving an equation. It's just that you have a slightly different sign there. You can at the end graph on a number line, or you may be asked to graph on a number line. There is one little twist that you need to be aware of. So if we take a look at some of these numbers, and if we have a look at an equation, say 1 is definitely less than 2. I think everyone agrees that's true. 1 is less than 2. But now if I happen to multiply both of these by a negative number, let's just do negative 1 times them and negative 1 times that. So I'm multiplying both by a negative number. 1 times negative 1, 2 times negative 1, negative 2. Have a look at that now and tell me which one is the larger number. If you think about it, negative 1 is larger than negative 2. So what happens is if we multiply by a negative, we have to change the sign around. Similarly, if we start off with a number such as 4, it's less than 8. But if I now divide it by a negative number, divide both of them by negative 2, 4 divided by negative 2, negative 2. 8 divided by negative 2, negative 4. And again now if you have a look at what's happened is this number is now larger than this one. So again I'm changing the sign. So a bit of a rule for inequations is that when multiplying or dividing by a negative number, you change signs. I'll do one more example to show you how that works in practice. Make sure you have a note of this in your books. So we've got a little bit more complex, a few more steps involved. As usual, we want to get x on its own. We're going to remove this 8, so I'll subtract 8. The 8 itself is positive, so inverse operation, subtract 8. Making sure I keep that all there, negative 2x on 3 is greater than or equal to negative 4, take away 8, be careful with this one, negative 12. From there, let's multiply both sides by 3, so times 3 and times 3, get negative 2x is greater than or equal to negative 36. Finally, I want to divide by the negative 2. It's negative 2 times, divide by negative 2, divide by negative 2. This is one thing different in equations. When you divide by a negative, you change signs. X is less than or equal to 18.